Today, in the Monday Certified feature from Bare Metal Cyber Magazine, we are looking at Certified Secure Software Lifecycle Professional, often shortened to CSSLP. This is a specialized cybersecurity certification from ISC², and it focuses on security across the full software development lifecycle. That means it is not only about writing safer code, it is also about understanding how security belongs in requirements, design, architecture, implementation, testing, deployment, operations, maintenance, and software supply chain decisions.
If this certification is on your study list, a free and complete audio course is available in the Bare Metal Cyber Academy at baremetalcyber.com, complete with a study guide and a second ebook featuring 1,000 flashcard questions.
For an early career cybersecurity professional, or for someone changing careers into security or software work, this certification can be useful even before you are ready to take the exam. It gives you a clear picture of what mature, secure software practice looks like. Instead of treating security as something that happens after an application is already built, this credential asks whether you understand how risk should be identified and reduced from the beginning of the software process.
CSSLP is issued by ISC², the same organization behind well-known credentials such as CISSP, CCSP, and SSCP. That matters because ISC² certifications are generally viewed as vendor-neutral professional credentials. They are not built around one programming language, one cloud provider, one framework, or one tool. The focus is broader. The exam is meant to test whether you understand secure software principles and can apply them across real development environments.
This certification is best understood as an intermediate to advanced application security and secure software lifecycle credential. It is usually not the first certification someone should attempt if they are completely new to cybersecurity or completely new to software development. The exam assumes that you can think across several parts of the software lifecycle and understand how decisions in one phase affect risk later.
The people most likely to benefit from this credential include software developers who want to move towards secure development, application security professionals, software architects, technical leads, quality assurance professionals, security analysts who work with development teams, and managers responsible for secure software delivery. It can also help professionals who review vendor software, evaluate third-party components, or help translate security expectations into practices that engineering teams can actually use.
The strongest fit is often someone who works between engineering and security. Maybe you are not only writing code and you are not only scanning applications after release. Maybe your work involves requirements, design reviews, threat modeling, security testing, release decisions, or discussions about software risk. That is the space where this certification makes the most sense.
ISC² carries weight in the security industry because its credentials are built around professional practice and continuing education. The organization uses job task analysis and exam outlines to keep its certifications connected to real work. That is especially important for secure software because the field changes quickly. Development teams now deal with cloud-native systems, third-party packages, automated pipelines, infrastructure as code, and increasingly visible software supply chain risk.
Maintaining this certification also requires ongoing professional education and annual maintenance. That model reinforces a basic truth about software security. Secure software is not a one-time body of knowledge that you learn and then never revisit. New vulnerabilities appear, development models change, dependency risk evolves, and organizations keep adopting new platforms. A professional credential in this area has to represent continued learning, not just a single test day.
The exam itself tests secure software lifecycle judgment. It covers secure software concepts, lifecycle management, requirements, architecture and design, implementation, testing, deployment, operations, maintenance, and supply chain risk. In plain English, It asks whether you understand how software can be built and managed in a way that reduces security problems before they become incidents.
One of the most important things to understand is that this is not only a secure coding exam. Secure coding matters, but it is just one part of the larger picture. You may need to think about how security requirements are created, how design choices affect attack surface, how testing supports release readiness, how software should be maintained after deployment, and how third-party components can create risk inside your organization.
The exam rewards applied thinking. A question may describe a software team trying to choose between design options, manage a release, assess a vendor component, prioritize a security requirement, or decide what kind of testing is appropriate. The correct answer often depends on lifecycle thinking and risk judgment. It is not always enough to memorize a term. You need to understand why that term matters in context.
A common misconception is that this credential is mainly for developers. Developers are an important audience, but they are not the only audience. Application security teams, architects, testers, program managers, and security leaders can also benefit. Modern software risk is shared across teams. That is why the credential treats secure software as a coordinated practice, instead of one final security review at the end.
Another misconception is that application security is mostly about finding flaws after software is written. Testing is important, but prevention is just as important. Requirements, architecture, and design decisions can either reduce risk early or create problems that are expensive and difficult to fix later. This certification helps you see that full chain of cause and effect.
The current exam is commonly presented as a 3-hour test with 125 items. It includes multiple choice and advanced item types, and the passing standard is commonly reported as 700 out of 1,000 points. Those mechanics matter because you need both knowledge and pacing. You do not want to spend too much time debating every question. You want to recognize the issue, understand the trade-off, and choose the best answer with confidence. A smart preparation plan starts with the official exam outline. Do not begin by randomly collecting application security articles or trying to memorize every vulnerability name you can find. Start by mapping the domains. Then ask where you already have experience and where you are guessing. A developer may feel comfortable with implementation, but weaker on governance or operations. A security analyst may understand vulnerability management, but need more depth in software architecture and development workflow.
A good study path begins with the big picture. First, understand secure software concepts and lifecycle management. Then move into requirements, architecture, design, implementation, and testing. After that, focus on deployment, operations, maintenance, and software supply chain risk. In the final stage, use practice questions to identify weak areas and review them deliberately. Hands-on practice still helps, even though this is not a lab exam. You can review sample threat models, study common software weaknesses, walk through secure code review concepts, examine how dependency management works, and look at how security gates fit into development pipelines. The goal is not to become an expert in every programming language. The goal is to understand how security decisions appear in real software work.
Busy professionals should use a mix of study methods. Reading gives structure. Audio helps reinforce concepts during commutes, workouts, or routine tasks. Flashcards help with terminology, domain recall, and quick review. Practice questions help you learn how the exam frames decisions. Discussion with peers can also help, because explaining why one answer is better than another builds applied understanding. This is where the Bare Metal Cyber Academy can fit naturally into a study plan. The free audio course developed by Bare Metal Cyber can help you build familiarity with the lifecycle concepts. The study guide can give you a structured path through the domains. The flashcards ebook can support shorter review sessions when you do not have time for long study blocks. These resources are not a replacement for careful thinking, but they can make preparation more manageable. Time management during preparation is just as important as time management during the exam. Because the credential covers such a wide range of topics, many candidates will have uneven confidence. Do not spend all your time on the areas you already know. If requirements, architecture, secure testing, deployment, or supply chain topics feel abstract, schedule extra review time for them.
As you get closer to exam day, practice explaining concepts out loud. Explain why secure requirements matter. Explain how threat modeling supports design. Explain why software supply chain risk matters. Explain how testing supports release readiness. If you can explain those ideas clearly without relying on memorized phrases, you are building the kind of understanding the exam tends to reward.
For career impact, this certification is strongest in roles connected to secure software delivery. That can include application security, software engineering, secure development, software architecture, quality assurance, security program management, software procurement.
Hiring managers may view CSSLP as a strong differentiator when the role involves software security. It signals that you are not only interested in finding vulnerabilities after release, it suggests that you understand how to reduce the chance that those vulnerabilities appear in the first place. For organizations that build, buy, integrate, or depend on software, that mindset is valuable. In a broader certification path, this credential usually fits after foundational cybersecurity knowledge and some real exposure to development, application security, or software assurance. Someone might build toward it after Security Plus, SSCP, or practical software experience. A person who already holds CISSP may use it to specialize in secure software. A developer may pair it with secure coding, cloud security, or development security operations training.
There are also cases where another certification may be a better fit. If you are just starting in cybersecurity, a foundational credential may be more useful. If your goal is cloud security, a cloud-focused certification may be more direct. If you want hands-on web application testing, a practical offensive application security course may be a better match. If your focus is governance, risk, or audit, a management or risk credential may make more sense.
The key is to match the certification to your work and your next step. CSSLP is not for everyone at every stage. It is most valuable when you want to understand how software risk is created, how it can be reduced, and how security can be built into the lifecycle instead of added after the fact.
For the right candidate, this credential can sharpen both career direction and daily judgment. It can help you speak more clearly with developers, security teams, architects, testers, and managers. It can also help you see software security as a system of decisions rather than a checklist of controls. The best audience for CSSLP is someone who already has some connection to software development, application security, architecture, testing, software assurance, or security management. It usually makes sense after you have built basic security knowledge and gained enough exposure to understand how software teams operate. If that sounds like your path, this certification can be a serious and useful next step. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.